In this video, I want to review the definition of an exponent and talk about the product, quotient, and power rules for exponential expressions. Remember that exponents represent repeated multiplication. So the same base is being multiplied a certain number of times. For example, x cubed means x times x times x. It's the base x multiplied 3 times. That was the exponent that we saw here. So when we simplify something like x squared times x to the fourth, what's going on with the multiplication? Let's expand each of those terms. X squared means x times x. X to the fourth means 4 x's, all multiplied together. So when I take x squared times x to the fourth, I'm going to have a total of 6 x's here, or x to the sixth. So how could you explain in words or in symbols what happened as we moved from here to here? Well, we added the exponents. And that's what the product rule is all about. In general, the product rule says this: x to the m times x to the n equals x to the m plus n. Let me show just one more example. X to the fourth times x to the eighth will equal x to the 12th just by adding the exponents together. Now let's think about a quotient involving exponential terms. We want to simplify y to the fourth over y squared. Each of these represents some repeated multiplication. So let's expand each of those terms. Y to the fourth is y times y times y. Y squared is y times y. Now we know that to simplify an expression like this, we divide out common factors. So I can divide out a common factor of y and another common factor of y, and what remains is simply y squared. So y to the fourth over y squared equals y squared. What happened with the exponents here? Well, in short, we subtract the exponents. 4 minus 2 gives us 2. And that's all because of the repeated multiplication that we see played out in every example. So here's the quotient rule for exponents in general. Y to the m over y to the n equals y to the m minus n. Now what about an example like this where I have x squared over x to the fifth? Here the larger exponent is in the denominator. Let's think about how that would work. If I just followed this rule, I would subtract the 2 in this order, 2 minus 5, and that would give me negative 3. So I have x to the negative 3. We're not sure yet what that means. That's coming in a later video. An alternative way of viewing this is by expanding each of these terms and thinking about what we get. So x squared over x to the fifth, the expansion looks like this: x times x over 5x's in the denominator. We divide common factors here and here, and I end up with this. Numerator is 1, denominator is x cubed. So my result is 1 over x cubed. We'll see in a later video that x to the negative 3 is exactly the same as 1 over x cubed. Finally, let's think about what happens when an exponent is applied to a term that already has an exponent. For example, we want to simplify x squared cubed. We can expand this using repeated multiplication. X squared cubed means x squared times x squared times x squared. I can expand each of these and I get x times x for this one, times x for this one, times x. So that's a total of 6 x's. What happened with the exponents? Well, we multiplied them. 2 times 3 is 6. X squared cubed gives us x to the 6th. That is the power rule for exponents. X to the m raised to the power of n equals x to the m times n. Here's another example. If I have x to the fourth raised to the power of 5, That's a lot of work to expand, but that will give me x to the 20th. 4 times 5 is 20. The power rule applies even to exponential terms that have a product or a quotient inside parentheses. For example, I could look at the term 2x cubed. This means 2x times 2x times 2x, right? And so we see if we collect these terms, I'll have 2 times 2 times 2, 2 cubed, x times x times x is x cubed. This exponent of 3 was applied both to the 2 and to the x through multiplication. So I have 2 cubed, x cubed, which is 8x cubed. Some people call this a different rule of exponents. I think that it just follows from the power rule and what we've seen already about repeated multiplication. One final example might be with a quotient. Say I have y to the 5th over x cubed, and that's raised to the power of 4. This is repeated multiplication 4 times, and I can demonstrate that shorthand simply by multiplying the exponents of every term in the parentheses. So I'll have a result of y to the 20th over x to the 12th. This outer exponent of 4 distributes through multiplication to all the exponents inside the parentheses. I end up with y to the 20th over x to the 12th. Before I end this video, I want to address one very common misconception when it comes to exponents. If I have x plus y squared, remember this is repeated multiplication for the whole base x plus y. So this means x plus y times x plus y. That is not equal to x squared plus y squared. That's something different. So in short, exponents do not distribute across addition or subtraction. X plus y to the power of n is not equal to x to the n plus y to the n. X minus y to the power of n is not equal to x to the n minus y to the n. Exponents distribute across multiplication, not across addition or subtraction. So the only way to simplify something like this is to actually multiply it out for the given number of times. Let's watch out for that misconception as we move forward into simplifying exponential expressions.